Okay, let's do an example. So the different problems in this section each ask for different things. So read the directions very carefully. In this problem, I'm going to ask for intercepts, vertical asymptotes, horizontal asymptotes, domain and range. And then I'll ask for a little bit more information about the vertical asymptotes. So we'll get to that at the very end. Here we go. X-intercepts. Those are the places where the numerator is 0, making the whole function equal 0, right? The y value is 0. Where is x plus 2 equal to 0? Right, that's at x equals negative 2. So my x-intercept is negative 2 comma 0. Negative 2. Alright, my y-intercept happens when I let x equal 0. So f of 0 is equal to 0 plus 2, which is just 2, over 0 plus 0 minus 10, so that's just negative 1/5. So I have 0, negative 1/5. Would be down here-ish. Is this beautiful? No. I'm okay with that. Vertical asymptotes. Things that make the denominator equal to 0. Well, this would be easier if I factored it. X plus 5 and x minus 2. So the vertical asymptotes are at x equals negative 5 and x equals 2. Okay. Horizontal asymptotes. Now, this is where we don't care about the rest of this, just the first part. The degree of the top is less than the degree of the bottom. So the denominator is larger than the numerator. Y equals 0 is my horizontal asymptote. I'll fill that in. Now remember, you can cross a horizontal asymptote, but your graph can't ever cross a vertical one. The horizontal asymptotes are only talking about the end behavior. So in the middle of the graph, you can cross it as many times as you want. Alright? It's not the same with vertical. Alright, we can fill in domain and range right now. My domain, well, clearly at negative 5 we have a problem, and at 2 we have a problem. So I can have a graph from negative infinity up to negative 5, but not including it. And then from negative 5 to positive 2, not including that. And then from 2 to infinity. So I'm going to claim, but my graph will bear it out, that my range is all real numbers. We need to fill in the rest of the graph and make sure. Okay, so let's look at a point like negative 4. If I plug in negative 4 plus 2 over 16 minus 12 minus 10, 1/3, it's going up. This graph here is going down on this side. I'm going to get a graph that looks like this. Up here. Down here. You can also use your graphing calculator to give you whether the graph appears on the top or the bottom. Okay. Some problems ask you to talk about the behavior of the graph at the asymptotes using limit notation. We did this early on and I confused everybody. We're going to try it one more time and see if you understand. So at negative 5, the limit as x approaches negative 5 from the positive side, that would be from over here. Is that going to give me positive infinity values or negative if I approach it from the positive side? Good. If I approach, x approaches negative 5 from the negative side, I'm going to get, going towards it from the negative infinity. Okay? I can do the same thing for 2. And it would look like this. You only have to give this limit notation at the asymptotes if the problem specifically asks for it. I do not need to see it every single time. Okay, so we're going to do one more example, and this one has a degree that's higher on the numerator than it does in the denominator. It's a higher degree polynomial there. So quickly again, x-intercepts, that's when the numerator is 0 and makes the y value 0. So x squared minus x minus 2 factors into x minus 2 times x plus 1. So we have x-intercepts at positive 2 and negative 1. Okay. Y-intercept, you make x equals 0. We get 0 minus 2. Okay, so y equals negative 2 over, plug in 0, negative 3, that's 2/3. So somewhere low like that, 2/3. All right, asymptotes, that's x equals 3, right? Let's go to 3, make a vertical asymptote. Now let's look for horizontal asymptotes. Well, the numerator has a higher degree, like we said, so if I ignore all of this and ignore all of this and just plug in something like a billion, right? I have a billion squared over a billion, they cancel, I get, oh, that's really just canceling x squared over x, that gives me y equals x. So I have a slant asymptote at y equals, right, x squared over x, you cancel, you just get x. Okay, that is this line, the y equals x line. So I'm going to write y equals x here. Now what does this graph look like? Well, we can at least do domain. It's going to be all real numbers except positive 3. And for range and extrema, I'm going to ask you to just plug it into the graphing calculator and look at it, because this is complicated. Now I'm also going to ask you to plug in for y2, y equals x, and look at it. And what you're going to see is that this slant asymptote that we have goes right through the function. You can cross horizontal asymptotes, you can cross slant asymptotes, because they're all about end behavior. They're not about what happens in the middle of the function. So let's go ahead and sketch this in, or I will. You might want to make your maximum y value like 20. That should give you a nice graph. Okay. So now, in order to find the range and the extrema, you just are going to use your graphing calculator. Second calc max, and find the maximum here, and then min and find that one. It looks like there's a max at 1, 1, so I redrew my graph to look nicer. And it has a min at 4.99999, I'm going to call that 5, because if I round anything, I get 5, 9. Okay, so now let's look at the range. Can you get every single y value from negative infinity to positive infinity? I don't think so. You can go from negative infinity up till to 1. And then you don't get any y values in your graph until you get back to 9 and go up to positive infinity. Alright? So I hope you're getting better at this. Make sure you can actually find those on the calculator, and then go ahead and start tonight's assignment.
Hey Jamie, how come you never see a pirate cry?
'Cause if they do, it's a privateer.
good enough.